Dear colleagues, I am Ma Shu, and I'm delighted to be here to communicate with engineers from around the world. I would like to introduce the application of Allplan in intelligent construction of East Lake Bridge. Xing Transportation Construction Group Company, Limited, is a leading comprehensive service provider for the entire industry chain of infrastructure construction. Its business scope includes highway, municipal, construction, water conservancy, etc. It is a well-known innovation and practice base for corrugated steel web composite bridges. The technology has also been applied in this project. These are some lists of our main projects. The East Lake Bridge is located in Handan City, Hebei Province, China. It is a composite bridge with a main span of 150 meters, consisting of corrugated steel webs and concrete deck. It is a double-layer, double-tower cable-stayed bridge. The main parameters of the bridge are shown in the table. Among them, the main section is a corrugated steel web composite section with a single box and 5 cells, and the pedestrian passage is cantilevered using steel plate beams, supplemented by truss beams for decoration. This is an introduction video of the construction process of East Lake Bridge. The whole project has a total length of 6.45 kilometers. The East Lake Bridge is a controlling part of this project. The foundation is drilled using the rotary drilling pile technology. The lower pylon is poured in 4 stages, and the upper pylon is poured in 9 segments. The main girder is casted using a moving hanging basket cantilever method. After the bridge is closed, pedestrian passage components are installed. Finally, pour the bridge pavement and install ancillary facilities. The application of BIM technology should not be limited to the level of three-dimensional geometric shapes. The higher the precision of the model, the more effective its application will be. In 2021, China issued the Unified Standard for the Application of Highway Engineering Information Models. The accuracy requirements and application fields of BIM models have been proposed for various stages, such as preliminary design, construction drawing design, construction process, and final acceptance. We established the BIM model with L4, zero accuracy using Allplan, and applied it to each stage marked in blue in the figure. The specific application details are shown in the figure. Next, specific introduction will be provided on the important applications. We used Allplan to establish a detailed reinforcement model for the upper pylon, evaluated the construction feasibility, and calculated the amount of rebars used. The works for lower pylon are also performed. This is the detail modeling of reinforcement for upper and lower decks of composite girder. By the way, Allplan Bridge's parameterized modeling function based on root and cross-section allows us to quickly locate the cross-sectional position and contour of the entire model, as well as the position of bridge piers, and update them quickly according to route changes. Detailed consideration has also been given to the connection between the bridge deck reinforcement and the steel web. Also, the reinforcements near steel anchor box are taken into account. The shear nails for bridge deck and the connection keys at the edge of the web were also simulated. This is another perspective. For steel structures, the layout of reinforcement and pre-stressed tendons holes are considered as well. This is another perspective. Optimized design and safety analysis of large temporary structure are performed for upper pylon template. For the lower pylon, we have corrected many details that were not considered in the design process through precise simulation, providing assurance for the smooth progress of construction. The hanging baskets are modeled and construction simulations are performed. Details of hanging baskets. The disc-type scaffoldings are also modeled. Optimized design and material statistics for stiff skeleton for pylon construction are performed. For some repetitive components and components that vary according to certain rules, such as corrugated steel webs, steel structures for pedestrian walkways, truss decorative structures, connection components between the main tower and steel cables, steel templates, etc. We have improved the efficiency and accuracy of modeling through secondary development based on Allplan. This is an introduction video of the modeling tool developed to improve modeling efficiency. The corrugated steel web can be inserted into the corresponding positions of the bridge according to different parameters such as length and height. This is the view of pedestrian passage structure and truss decoration structure. Large-scale bridge models and souvenir models were able to be 3D printed using Allplan's model data. We also converted Allplan BM model to CAE model successfully to do finite element analysis for some purposes. Allplan model could be converted into not only truss, beam elements, also shell and solid elements. The reinforcements could also be converted as embedded rebar elements, so that crack analysis for complex stress structures or hydration heat analysis for mass concrete could be performed effectively. In summary, we have achieved many successful applications in intelligent construction for East Lake Bridge. The key reason we could do those are for Allplan's powerful and efficient modeling functions, convenient secondary development capabilities, and open data compatibilities. We would like to express our gratitude to Allplan team. As a part of intelligent construction, we are also combining Allplan for intelligent processing of reinforcements. Quick parametric modeling including geometry and reinforcement, segmentation of bridge components such as box girders for easy assembly construction, automatically and optimize the cutting of reinforcements based on fixed length and overlap specifications. The reinforcement processing data are automatically transferred to the MES system. Afterwards, the data will be automatically imported into CNC equipment for processing. Finally, assemble into components for prefabrication or on-site installation. Finally, thanks to you all for listening.